Another topic is unmanned shipping. As an obvious technology hype, autonomous and remote operated vessel supporters promise huge cost reductions, improvement in safety. There are different test projects and trials. IMO has started to consider the relevant regulation and so on, but I'm ready for unmanned shipping and how the future of unmanned shipping would look like and where we are now on this way to this future. Definitely, all these topics are discussed widely, but today we would like to step away from traditional academic discussion. We would like to take very specific examples, very practical examples of this topic, and put them with the same very practical view of representatives of actually consumers and regulators of shipping industry, and so we name it the panel battles framework. During the panel battles, our speakers will make presentation about their solutions. Then, together with our experts and together with our dear guests, we will try to look at the feasibility and benefits of this solution. Also, since we will have limited time on the air, and we will have also remote audience viewing us via broadcasting, we will have such tool as online voting. So we have prepared for each panel battle several questions, and during the discussion I will ask you to go to this questions webpage and you can select options, and in such way we will try to gather opinions of all participants of our conference, not only speakers and experts. By the way, I would like to thank our sponsors, FBC general sponsor and Fox News media sponsor, and all these questions as well as broadcasting are arranged at the website of Compute, and there you will also could find later the record of our conference as well. And after the panel battle, we will have short break again, coffee tea break, and then we will proceed to discussion on the maritime robotics. So this is topics and the framework of our today conference. So now I would like to introduce our honored experts and speakers of the first panel battle. So on the right side, I'm glad to introduce Vitaly Kluy. I'm an expert and representative on Russian Maritime Administration. Vladimir Nekrasov, Senior Technical Superintendent, FCF, shipping company. And also please greet our third panel battle speakers. Don Staffen, Vice President, Executive Vice President, Shipserve. Dr. Jin Hyun Park, Korean Research Institute of Ship and Ocean Engineering, PMO to Smart Navigation Project. Dmitry Syadosov, Managing Director, Canals Management Consultants, and Alexander Potemkin, R&D Director, Crankside Technologies. So, please, I would propose to start our first panel battle from a presentation of two projects, of two navigation implementation projects in Russia and in Korea. So, I would ask Alexander to start our panel battle. So, please put them presentation on the screen. And your turn. Please keep in mind that we have up to 7-8 minutes for each speaker, and I will control the time. So please, Alex.
Thank you. Dear colleagues, thank you for giving the opportunity to speak at this conference. My name is Alexander. I'm a Research and Development Director of Construct Technologies company. But first, let me say a few words about our company. Construct Technologies is a national leader in the field of digital technologies for marine and river transport. Construct Group has been operating in this market for more than 25 years. And now we are part of the largest Russian financial corporation, Sistema. We are the only Russian technology company to become a member in IALA association and is actively involved in the implementation of navigation in Russia. Construct Technology is a contractor for developing business roadmap Marinet by the order of National Technology Initiative of Russia. The company takes part in development of business roadmap for improvement of regulation of Russian Federation terms of e-navigation and unmanned surface vehicles. I'm glad to inform you that at the end of 2016 we began the creation of the first Russian e-navigation testbed. This project has been performed by Kronstadt Group in cooperation with our partners. The customers of this project is the Ministry of Transport of the Russian Federation and Marinet. General implementation period is from 5 to 6 years. The name of the testbed is Hermitage, in honor of the famous museum in St. Petersburg. Yeah. The next slide shows the borders of the testbed. The testbed is located in northwest of Russia near St. Petersburg city. It includes sea and river segments. The sea segment consists of the eastern part of the Gulf of Finland in the area of responsibility of Russia. The river segment includes three parts: the Neva River, Petri and river parts, Ladoga Lake, Lagostrian parts, the Svir River sluice part. There is some information for you to understand the situation with the implementing of technology in navigation in Russia. So at present this program is being developed and funded in two directions. Firstly, within the framework of the federal target program GLONASS, commissioned by the Ministry of Transport. This R&D is C. Secondly, within the framework of state program National Technology Initiative and its sub-program Marinet. This R&D enough within the borders of the Gulf of Finland. By their goals, these two programs harmoniously complement each other. Back to our testbed. Here you can see the C segment, vessel traffic service, automatic identification system, differential global positioning system, electronic chart display and information system, and unmanned surface vehicles. This slide shows the ship transition from the Neva River to Ladoga Lake. Here you can see the river segment, the second VTS, AIS station, water level meter, synthetic automatic identification system, ATOM, and unmanned surface vehicles. During this project, in cooperation with our partners, we have equipped the onshore and marine segments testbed. For the marine and the river onshore segments, we installed two VTS without sensor for coastal VTS that is located in Petrovac and river VTS that is located in Shlisselburg. In 2018, another three VTS will be deployed. For the marine and the river ship segments, we installed 12 AGDIS with e-navigation function. AGDIS were designed for ships of the Northwestern Basin Branch Rosmor Port and Basin Administration Volga-Balt. In addition to the testbed, we elaborated personal pilot kit navigation application for pilot organization, water level meter that provides information about the water level by GSM communication in VTS. Synthetic AIS ATOM sends information about your location by GSM communication or Iridium. ENC remote technology transmission system. Access to the internet, ENC database, etc. via Wi-Fi for a range of up to 3 kilometers. A few words about our promising project implemented in Hermitage testbed. VDS, model of the VDS coastal shipborne equipment. Automated hydrographic traveling system for high precision and reliable detection of object lying in the seabed. New version of our FDs on Linux with navigation functions. Model of Russian segment of the Maritime connectivity platform. Thank you very much for your attention. I hope my presentation has been useful and interesting for you.
Thank you, Alexander, for the presentation. Thank you for your time. And I would like to ask Jean to continue with the Smart Navigation project. I ask you to put on the screen the second presentation on the Smart Navigation, please. Yes, correct.
Thank you so much. Yeah, my name is Jin Park from Smart Navigation Project Office of CRISO. And I'm the head of systems engineering and management team of Smart Navigation Project Office to limit all the development of the process for the project. We are around at the center or the middle of the project period. So we have started our feasibility study for Korean implementation of navigation from 2013, but actually we could start our project in July of 2016 after the feasibility studies, which is required by the government guidance. If the research budget is higher than some threshold, we need to carry out the feasibility study before and getting fund from the government. So that took much time for us to start the actual project. So we will end the project will end at the end of 2020. So it's actually a 4.5-year project, not a 5-year project. So we are very, very serious on the numbers on where we are in terms of time. Smart Navigation project is more focused on non-large vessels because according to our statistics on the maritime accident, more than 80% of the accidents includes non-large ships. So if we want to decrease the maritime accident at sea, we need to decrease the accident, which includes or has non-large ships. So we would like to provide many number of services for non-large ships. And we are focused on the wider connectivity at sea. So we are installing the LTE network also on the coastline. Korea is not such a big country as Russia. We are a very small peninsula country. So that gives us a lot of chances for covering all the coastal areas with the wider band communication. So we are installing the LTE network on the coastline, which is about 100 kilometers from the coastline to the seaside. And the project is harmonized with international standard from S100 for the CMDS and the MCP, and especially we are responsible for developing maritime messaging service of the MCP, so which is one of the core components of the MCP. And the VDS and S-mode standardization is also one of our activity items, research items. So all the process is aligned with the systems engineering process, and we are in 2018. So we are more focused on the specialty engineering. You can see more things on that later. We are providing. We propose 6 services for ships. The first one is navigation monitoring and assistance service, which monitors or which provides maritime domain awareness to the government officers, which is in charge of assisting or monitoring the sea space. So if something would happen, there will be some alarms and assistance to the ship side. The second one is a shipborne system monitoring service. There are so many equipment on ship on board, so if we could see what is going on in terms of sensors on board, we could see more exactly what is going on. So this is dedicated for the passenger ships or the higher risk ships at sea in Korean waters. And the third one is ship the safe and optimal route planning service. If we use specify your destination at wherever you are, you could get your optimal route to your destination. And the chart would be updated in real time, and streaming service will be possible at the end of the project. And pilot truck assistance is very important because pilotage area is a very sensitive area in terms of safety. So we need to support the pilotage work in terms of connectivity and connected pilotage service. So pilot will have more information from the shore side. And the maritime environment and the safety information service, this is full set of information services to the ship side. This is overall architecture, and the connection between ship at sea and on board and shore side is provided with MCP. So this is important. And all the services are in order to change or exchange information with each other by using the PBS. We have carried out inspection last year, and we are now at some numbers of sprint, and so we will have some prototypes in next 2 months. And we have tested the feasibility on the LT net also on coastline. We identified that according to the standard, it guarantees 100 kilometers, more than 100 kilometers. It was proven by our experimentation. And we are drafting the S100 for the smart services. And maritime messaging services, we are in charge of maritime messaging service development, so which is kind of WhatsApp or messengers for maritime world. So with this, you can be connected with other maritime entities wherever you are and wherever you want to send this message. This year, we are focusing on the specialty engineering because we have something on our hand to test. Before that, we don't know what customer wants, so we have something to show them, so we could know what they want from now. So that is all about the specialty engineering perspective. And also, we are connecting some legacy or existing services, which is currently operable, by using the MCP and by using the web platform. That means if there is a service available from the shore side, that can be transmitted to the users via web platform. And so we call it the APP web. This uses the Baltic app and the open source. So the APP web, the Asia Pacific web, is the sister system of Baltic app. And currently we are working with US Coast Guard and AMSA of Australia. So there will be some service in conjunction with, in collaboration with 3 countries for providing services to ship at sea. And we have some test facilities for the sprint. And MCP is one of our main topics for the project. So I think this would be the connectivity platform for navigation and autonomous as well. And we are seeking for a chance to establish a consortium for the globalization or the standardization of the MCP. You are also invited as members of the MCP consortium. Thank you very much.
Could you kindly show
Thank you.
one more time a picture with the structure, please?
Okay.
Thanks a lot.
This one APP web or
No,
architecture?
previous one. Yes,
Yeah, this one, yeah.
thanks a lot.
Yeah. If you send me my picture to me, and I can send this item to you in
Okay.
high resolution with some explanation.
Thank you, Dean. So, before we go to discussion, I would like to ask to put on the screen our first question. Remember that we have online voting, so everybody in this room as well as everybody who watches via broadcasting can actually do very simple task, either to grab QR code or to input this link to the browser, and you immediately come to the web page with the question, and then you may select option. Which answer do you think is the most correct for this specific question? So I will do it by myself right after we will hear opinion of our expert, and I would like also to ask all guests also to participate in this discussion with our own questions and comments. So actually, my question is pretty simple. You know, we now heard about two projects. We know also about well-known European projects in navigation implementation. Overall, I believe that there are more than 20 projects in this area. So for today, we should more or less clearly understand what is navigation, which benefits could be brought by navigation. So my question, which I'd like to discuss, is navigation by itself is beneficial for shipping economics, for shipping business, or this is just something like a new mandatory tool which should improve safety, but which is not directly linked to the improvement of business. So, what is your opinion, colleagues? Who would like to start, please?
Okay, let me start. I don't think it is beneficial for the ship industry because the cost of navigation is quite huge, even compatible with a normal charts. Yeah? And what regarding this project, what is attractive? I'd like to ask Alexander, did you really drive hands-free over the Neva River?
I understand your point. So.
Or not? You just use the system to control your position or really drive free?
Very good questions again. Implemented our company testbed. We performed some tests that allowed us to think that this part of whole navigation framework, navigation technology, can help to ship owners or other services also work with each other with at the same time use communications via phone, something like that.
You know why I ask him? Because in-chat navigation, for example, for tanker vessel is already compulsory a couple of years, yeah? Nothing new with e-chat. Another thing, if you use DGPS, it's also DP system already implemented. We got the vessel at full control by DP system using shore-based reference system, using satellite, using reference system of the rigs, and at the same time e-chats, everything integrated in one bridge. Even we go further, we integrate the ice chat for ice navigation in this system. And the question is, did you really drive hands-free? Because all the other means is already implemented.
Let me sure. So let me maybe even to add and ask maybe also Jim to join the discussion. So the question is pretty simple. Please improve me if I'm wrong. So if we are talking about basic stuff for navigation, like e-charts, like DP systems, and etc., it is already in place. So what is actually new in navigation, which could be how to say, the next level of automation of shipping, of navigation? What do you see? Correct?
Yeah, absolutely.
I think we need to separate from the e-devices and e-navigations. I think e-navigation more about services from the shore side, more involvement of the shore side in navigation. So as you know, the navigation is all about, navigation has been and under the full authority of the captain on board. But we have more chances to provide more information to the ship side. Captain has more chances to have more precise and accurate decision. I don't think the navigation is almighty, because there's nothing in the world which has almighty for all purposes. But we can say that in some manner or in some position, navigation provide much information that we have expected. So in our case, to make it navigation compulsory or the regulatory, I think it requires much time. It takes much time because we need to see numbers to have some consensus. So we have started from the non-solar ships. We expect that we could show some numbers for that. With that, I think many maritime stakeholders will have more confidence on the navigation.
Okay, Jin, so actually you said that navigation should focus in navigation from onboard, actually navigation from onboard control to shore-based management control. Is it correct?
That controls some supporting.
Okay.
Yeah, supporting from the shore side.
Okay. Yeah, please.
I think all the navigation is driving to give another tool to the officers on board to identify potential targets and collision avoidance. It has not been designed for ships to do unattended sailing. And I don't think remote operations with the current communication status is feasible. So it's a system which has been designed for target identification and collision avoidance for solar vessels. Obviously, if you sail across the shore, you have to take care for the non-solar vessels. And the majority of the problems is coming from these type of vessels, because you have to do proper navigation as you used to do at the old time. Looking at the target, see the collision angle, and if this angle is changing, you are happy. If it's steady, you are in collision. So this is my opinion. Of course, navigation brought lots of information on board the vessel in a very useful manner. People can see with which target they are in collision and how long and after how many hours. The only thing that this navigation does not display currently is the intention, meaning at sea we don't have flashlights, so you don't know what the front vessel is going to do, turn left and right. This is where the problems are starting, and that's why 30% of the accidents on sea are due to navigation.
Okay, thank you. Vitaly, do you have any questions, please?
Good morning, everybody, and thanks for the invitation to take part in this very modern way of development of shipping industry. Absolutely. Distinguished colleagues, when we are talking about navigation, unmanned vessels, we should first understand the terms. And navigation is concept. It's not real equipment with the specific technical requirements. It's concept developed by IMO a couple of years ago and more or less formalized by some recommendations by IMO. And the idea of navigation is to integrate shipborne equipment and shoreborne equipment to allow those equipment to work together and to avoid mistakes, to provide more efficient information for ship crew, and to provide vessel traffic service staff with more information produced by ships and so on and so on. That's concept. When we are talking about navigation, we should divide in two ways, two directions. The first one is just equipment which in compliance with some regulations and some industrial requirements or standards. If the equipment on the same requirements and each unit understands other units in the system, whether it's located on shore or on the port, that means good communication and it provides more safe navigation. Integrated systems, it's much more difficult way, which I think will have no end. With some intermediate step in further development of unmanned vessels. We, I think, achieved some level of development of navigation, having a lot of equipment which communicate each other without involvement of persons, of men. That's quite achievement. And most of the equipment I mentioned standardized, if I may say. That's achievement of IMO, of industry, of IT people. I may understand careful approach of shipping industry, ship owners to e-navigation because they have their own life. They try to have their life as much easy as possible, not implementing new equipment if no special requirements, or if this new equipment doesn't create new money or save the expenses. They have direct influence on the business. If no feasible immediate economical influence, that's the problem. And I should remind the idea, I very like it from our Korean colleague, IT people, those who work with new technologies should show shipping industry the benefits, the product, and the final results, what the industry would receive if they implement. And after that, once industry understands the benefits, including financial ones, in the first instance, financial ones, then we may go ahead with regulations, with technical requirements, with asking industry to spend some money, some resources to more development. So, in conclusion, very sorry for long intervention. In conclusion, question of e-navigation is valid. I think it's a mostly completed project of IMO, even understanding that it's not finalized as it was expected in the beginning of the idea, but it's a very good step forward to provide more sufficient navigation through unmanned idea.
Okay, thank you. Actually, no, we are discussing now just to bring arguments for shipping companies, for the industry, why e-navigation or maybe solution or services based on e-navigation could be beneficial. Actually, it is an ideal kind of battle, and really saying, by the way, may I ask to put on the screen the results of our online voting? Because it is interesting for me to see how people evaluate, because what I hit for now, actually, I understand that e-navigation is more or less just a concept. So we should not expect from e-navigation itself some direct benefits. Is that correct? Okay. In spite on this opinion of by our experts, you see that online voting is pretty optimistic, that navigation itself can bring some benefits, and I would say that pessimists who say that no, navigation at all is not interesting for shipping companies and not too much interesting, they're pretty minor. I don't see exact numbers, but I think that this is the last voting option, correct? So, we don't stop on this. I want. It's time to go to the second part of our panel battle dedicated to the digital navigation. I'm not sure. Should we say this is opposite part, or this is a complementary part to e-navigation? Not looking at the title of our panel battle, where digital navigation is versus e-navigation. Yes, I'm talking about digitalization of shipping industry, of fleet management, of shipping operation, of logistics, as a result of new technology penetration to the industry. Actually, we all know about big data utilization in different other industries, and definitely the maritime industry would not want stay calm, correct? If you see, for example, Ubers in cities, why shouldn't we expect Ubers on the seas, for example, correct? At the same time, in contrast to navigation, which is concept, logistics and operation are very clearly areas of business which should generate direct economical value, direct economic benefits, correct? So we should expect from digitalization of these areas a pretty strong and direct positive impact on business. And I would like to discuss actually, is this a really opposite trend, or is it part of one whole together with navigation? Is it linked to navigation? I mean, all the digitalization of maritime operation or maritime logistics. With our next speakers, Mr. Dimitri Feodosio and Mr. Donald Staffen. So, Dimitri, may I ask you to share your opinion on this point, please?
Thank you. Thank you. First of all, thank you very much for giving me the opportunity to present our work in terms of autonomous vessels and vessel digitalization. We are living the post-industrial revolution in shipping. This is the question. The shipping IT started back in the 80s when we started having the first ship-to-shore communication and the personal computers and so on. And it was all about collecting and analyzing information. And then the internet came and the e-commerce. Some of them proved to be true, some of them proved to be hype. But no matter what, it was all about collaboration. So collaboration is another part that the information technology is bringing to the shipping industry. And nowadays, the extension of collaboration is the blockchain. And nowadays we are talking about artificial intelligence, and nowadays we are talking about cybersecurity, and of course autonomous vessels. The Internet of Things and the big data, it was a very hot topic some years ago. Some people, it was all about the digital vessel. Some people believed that it would bring the end of the science, so we don't need to know anything. The big data will give us all the information. And of course, the open systems is a very key point. So new technologies do not depend on big companies. So how shipping will look in the future, God knows. It depends on regulatory compliance, it depends on technical limitations, and of course on the financial aspects. And on the financial aspects, things are very simple. Unmanned vessels will cut on crew costs, and the crew cost is a big part of the running cost, so it makes a 30 million vessel from loss-making to profit-making. So, definitely, autonomous vessels will be much simpler and much cheaper vessels, and definitely safer than today. It will minimize the crew cost, it will probably use alternative energy sources, and we need new regulations, management operation styles. And if you give me an enter,
We have problem with the screen.
yeah, play that. So this is the announced first autonomous vessel. It's going to be in operation 2019. It's going to operate in a restricted naval base for the Greek Navy, carrying 200 people from one side to the other. And this is our model. And so lots of ships are in progress, so do collision avoidance. And of course, we don't use navigation for this collision avoidance. And of course, for certain countries like Greece, it's a matter of national pride. So, how unmanned vessels can capitalize, research we have done for unmanned vessels can be capitalized nowadays, so we have to wait till 2020 to start thinking what to do. Lots of companies like Rolls-Royce in the past and us released the Intelligence Supervisor, which is the ultimate situation awareness and emergency response system. It uses machine learning in order to read information from instruments and sensors, and also artificial intelligence to collect visual information and analyze them. So detect oil on deck and stop the bomb probably, and it takes action. It all wants the crew. And this system is available in the market. We have installations of several vessels. So unmanned vessels will come in between systems using artificial intelligence can prevent the human from mistakes which cost money. And this is how our system looks like, another interplay. This is how the oil detection system looks on board. Yeah. So you get an alert, so if somebody does not watch that by listing the vessel and shifting fuel from one tank to the other, they overflow the tank, probably the pump will stop. And of course, you will hear lots about in navigation by artificial intelligence, and for that reason we use either cameras which are cheaper or LiDARs which are more expensive, and of course long or short-term sensors for short collision avoidance. Now, on the digitalization side, Danaos has, I think, a very robust system in terms of streamline analytics, in terms of performance. So by using sensors, and you can get alerts and graphs. The alerts are very important because they translate the graphs. So instead of having your superintendent engineer looking at the graphs to end up to a conclusion, the system sends him a message. The added value we brought to that, we applied the optical digitalization using machine learning techniques. By taking photographs of the instruments, we can get the digital information of the instrument. So that avoids existing vessels to put the sensors and rewire the whole vessel in order to collect information to create the appropriate situational awareness and digitalization. And of course, Danaos has a complete range of ship management systems, starting from financial to deep technical. So we have optimal routing systems, and this is the techniques we are using for collision avoidance. So we don't use artificial intelligence, we use dynamic programming at sea, much safer. And this is the benefit you can have. You see the passage plan costs around $210,000, the optimal routing costs around $1,008,000, so you save money there. And of course we use the devices on board, we use electronic charts, electronic drawings for procurement, as Don will explain later on. We support human language support for the management, to ask the computer what is the running course and the computer to answer with the appropriate answer. We use big business intelligence to create insights. We fully comply with GDPR and cybersecurity. We have Danaos One, which is the optimal collaboration platform, which nowadays has blockchain, and of course supporting house development, lots of functionality and fully customizable. And this is what Danaos is doing. Thank you very much.
Dimitri, and before we will go to discussion, I would like to ask Don also to add his thoughts on this topic. Could you please open the next presentation?
Thank you, Alexander. There we go. Thank you, Alexander, for inviting ShipServe to participate here. So the topic that we were asked to look at was, can the digitalization of the marine supply chain live up to all the hype? And I would say for most of the 20 plus years that we've been doing this, the answer is no. But I think we're just starting to get it right now. Now, it starts with data, and first you have a little data, and then eventually you have a lot of data, which gets out of control, and someone who made a lot of money as a consultant decided to call it big data. I didn't come up with that. But how do we get big data? Well, you start with crowdsourced information, and Google and LinkedIn are both great examples of crowdsourced information. But it's not enough. You also want, there we go, you want trading history, which is something like Amazon. And if Google and Amazon ever got together and had a child that was devoted to the marine industry, we would hope that it would be ShipServe, because we take both of those components and put it together. Now, as you can see from our volume numbers, it took us quite a number of years to get it right. But in the last 10 years, you can see that the volume has taken off. And we're at the point now where about $3.5 billion of trade every year is going through the ShipServe platform. And that gives us the transaction data that we need to be able to start to helping people. We were talking about manned versus unmanned ships, and Demetrius correctly mentioned the effect on the cost of running the ship. But whether it's manned or unmanned, you still have a lot of stuff that it takes to keep the ship going. And so we're focusing on controlling the cost of all of that stuff. The deck stores, the engine stores, safety equipment, and so forth, and to be able to control that. And it's not just one part of the industry; it's all parts of the industry. It has to work for everyone, everything from a cruise ship to a tanker to a ro-ro, all the way down to an offshore supply vessel or a dredging ship. So that's the trade, and as you saw, we've successfully gotten a critical mass of that. The crowdsourced side is that we've spent the last 12 years putting together our own Google for the shipping industry, which now contains over 70,000 suppliers, and for the first time also now includes the IMPA Marine Stores Guide, which is the most commonly used international standard for marine stores. So you have big trade. I came up with that name, big trade. And the crowdsourced key information, and that makes up the big data, at least as we see it in the marine supply chain. But once the data exists, now what are you going to do with it? Well, you have to have smart questions in the form of good queries, and what has to come out of that is meaningful reports and useful interpretations. And some of the ways that we do that, for example, is that we show suppliers how they are interacting with the market and with individual customers through their quote rates, their win rates, their cycle times, whether their customers are price sensitive or time sensitive. And they can drill down on a customer basis to try to improve their relationships with each customer on the basis of all of this information that we have. On the shipping company side, we do the same thing. We have reports and analyses that let the shipping company look at their relationship with each supplier of their procurement operation as a whole, and then compare it to that $3.5 billion of trade. And so, for example, what you see here is on the left side, the three bars there show it shows the shipping company how price sensitive they are by indicating that 70% of the time with this supplier wins when they're the cheapest. And the second bar is all suppliers. So this says that this shipping company is awarding to the cheapest bidder 80% of the time. Now, if that's intentional, that's fine. But sometimes that's a surprise because some shipping companies think that they're not being price sensitive, that they're more quality sensitive. And then you show them information like this, and they didn't realize that. The same goes with time sensitive. Do they always just take the first response, or do they wait until they get multiple responses? And then we extend that by, should you be getting responses at all? Or should you be generating contracts for certain items versus spot purchases? So this kind of information lets them make smarter decisions. And so when we take those two together, we call it big analytics. We came up with that too. But even those, that's not enough, because you have to help people make it all happen. And so as ShipServe, we look at how we get between the buyer and the supplier, and we create opportunities for big collaboration. So not just between the shipping company and their lube supplier, or the shipping company and their paint supplier, but the ability to scale it, so that for 1,000 suppliers that a shipping company might have, even if they may manage 3, 4, 5, 600 ships, they can still have meaningful conversations with the suppliers and work towards win-win situation that lets the supplier make money and still allows the shipping company to cut their costs. And then it has to go along with big service. Shipping is a global industry, and one of the reasons that shipping has been behind other industries in automation is because other industries don't have their factories move all the time. And so you have to be where the ships are, where the suppliers are, and where the buyers are sitting 24/7. So we call that big service. And it has to be reliable. You have to be up 24/7. You can't have downtime because then things stop. And as we've been seeing more and more in recent years, you have to create the trust over a long period of time that can never be violated. GDPR is a response to people who did not create that trust. And so now becoming compliant with that is what all industry has to do to reestablish that trust. We're glad to say that we've had it for the 18 years, but we recognize that the standards continually increase and evolve. So to summarize, you have big trade, crowdsourced key information gives you big data, and by asking the right questions and presenting it the right way, you create big analytics. And then this is underpinned by service, collaboration opportunities, and trust. So, thanks for listening.
Thank you, Don. Thank you for the great points to continue our discussion. First of all, I would like to ask again to put the next question on the screen. And don't forget to vote. By the way, if you want to just take from this paper QR code or link, and so please take your smartphone and participate in the online voting. So the question is very simple. We see, I would say, another angle of another area of digitalization. Maybe this area is more beneficial for shipping companies rather than navigation. And maybe we should put more attention, including attention of regulators, to this area to stimulate digitalization of operation of logistics. What do you think? Who would like to start, please? And by the way, dear guests, if you have again any comments or questions, just please raise your hand. We have a couple of microphones in the room, so we will be glad to hear your opinions as well.
Yeah, thanks, and thanks, Dan, for excellent presentation, which is quite exciting. We discussing two quite separate topics. First one, first part of our discussion was very technical one. The ship is part of metal with the people on board. So how to manage it without any commercial using of this very good equipment for human being. And the second point is commercial part of shipping, which is connected with the first one, but I prefer to say not connected. It's absolutely standalone direction to development. And I think the ship owners and most, not only ship owners, but all the companies, all the players in the shipping industry should be more involved in digital world, in digitalization of operations rather than it done now. As an example, I may say that very recently Maritime administration started to produce electronic certificates for vessels. The idea I first heard 10 years ago, I think, and the regulators were very, very careful with the exception of electronic certificates of the vessels, but now it's live. And FAUL's committee, facilitation committee of IMO agreed that electronic certificates may be used, and now many administrations already introduced electronic certificates, and many port states accept, not many, all of them should, accept electronic certificates. It's not easy task, but it's going on. The next step is electronic certificates for ship crew, and very recently IMO had hearing the submission of the Russian Federation how to treat electronic certificates of ship crew. And finally, they decided that it could be possible. No one administration produced, as far as I know at the moment, but I think many of them preparing to issue electronic certificates. This promotes life, which is not slow now. We are running every time, but we start running more. For commercial part, I think we should do more providing digital world for circulation of commercial data, commercial relationship of all players in this shipping industry, cargo owners, ship owners, brokers, suppliers, whatever. And I think we have no choice. It will be done. The question only of timing. So those who will be ahead will win. That's my feeling. Thank you.
Okay, so actually you said that from point of view of overall digitalization process, this area is extremely important, and we believe that it should be regulated as well. But you think that navigation is navigation, economic is economic, and they are not too much connected. Is that correct? Linda, and what is your point of view? Is navigation by itself, is it not too linked within the shipping company with economics, and vice versa?
Just to comment on my presentation, it's always nice to hear from two famous companies. Actually, I worked many years with the NAO's accounting program and with the ShipNet purchase program. Right now, we switch over to another one, just more positive. And of course, navigation, purchase, everything right now connected in one system. What we are doing in NCF is that one electronic system which connects all means of control, including operational, purchase, technical data. So anytime in the office you got some results on your desktop for analytic and for do right choice how to do it and how forward to see. So digitalization, yes, of course, we should go further and further. Something can still keep us behind to have a success. The one point that's very important is the communication means with the vessel, which we discovered due to huge data to be transparent. This is cost of time, and even research is not reliable for such purpose. Another question, which you start, unmanned vessel. Of course, we are very interested as a ship owner. We are very interested because right words regarding this OPEX of the vessel, operation expensive, up to 50%. This is expensive for crew. If the owner can reduce it, if the government allows us to do such things, to bring dangerous cargo with its main safety of people and environment, of course we will do it.
Okay. Yes, please.
If I could just address what Vitaly said before. You asked the question about the regulation and also whether the two are linked. I think that with the regulation, what happens is that the regulation can cause everybody to advance at once, even when they didn't want to. This is my global entry card in the United States. This allows me to get into any port in the U.S. This wouldn't have happened if not for the regulations that followed 9/11. The question then is would this be the most economical way to do it? And frequently the regulations don't take economics into account. As to whether the e-navigation and the supply chain are linked, they're not from a technical standpoint, but they are from a personality standpoint and a culture standpoint. The trust that you have to be willing to consider unmanned vessels or moving some of the responsibility from the shore, from the ship to the shore, it's a different way of doing things. And we've faced the same thing in the digitalization of the supply chain. I remember 14 years ago, I was talking to a purchasing manager of a German shipping company, and he said, I will not use e-commerce because my buyers learn by typing prices into my system. And that's what he really believed. Now, I don't think that person believes that anymore, but it's the same philosophy that has to change in order to be able to embrace these new types of technology, to be able to trust them, and to know that they're going to move your business forward.
Thank you for a very valid point. I think that when we say about innovation, we are talking about not even about concept, but we are talking about something like an umbrella. And under this umbrella, we are talking about digitalization. We are talking about, for example, as Dimitri said about unmanned shipping. We are talking about links between different parts of management of shipping companies and so on. So this is maybe very interesting point that innovation already is not a concept, it's something like mindset. So which could bring just new ideas in overall shipping industry. Please, I would like to ask our dear guests, maybe you have any comments, questions before we will wrap up the first panel battle, please. Any ideas, any comments which you would like to add?
One comment.
Yes, please.
I mean, regulations currently, in terms of digitalization, are two good stuff. Meaning, if you look at the new TMSA 3, it gives vessels having performance monitoring systems and performance optimization the benefit of better ranking and better charter parties. So you see regulations, I mean, not IMO regulations by clean navigation, but regulations made by the automators, they try to sort of give the benefits to the vessels that apply modern practices in terms of better market share. And this is what we expect to see. And we were very impressed to see that with our IS, the biggest clients are not shipping companies, are insurance companies. P&I clubs are coming to us and say, we will support you in order to promote all that on board the vessels of our clients. Because at the end of the day, they pay the bill. Thank you.
Thank you. Please, may I ask you to put the results of the voting on the screen? I mean, the last question. Yep. Yeah, sure, definitely. So, please.
I'd like to say that there is some differences between the innovation and digitalization. I'd like to say that innovation is all about harmonization between every components on board and between every services on shore. So all these entities are harmonized together. Then the navigator could be more comfortable in their navigation, more safe in their navigation. That is innovation concept. In case of digitalization, I might say another term. Numericalization is the right term for that. Because if we have many numbers on many things in our business, we can get more tools in a right way. Not just a click, but with number, we can predict the future, or we can also make a fact impact in a good way. That is digitalization. So I think if we regard it as numericalization, numerical shipping and numerical management, that will be more appropriate for to understand what is real meaning of digitalization.
Thank you. So please, looking at these results, I see that your point that this area should be regulated and should be in the focus of attention of regulators and industry as well is accepted. But at the same time, I think our audience doesn't divide innovation from logistics and operation from this regulation process that recently has changed. And again, you know, for me, for example, as a personal output from our first panel battle, is that means that we understand innovation really as an umbrella, as a flag, as a banner. So we are not talking about, how to say, direct utilization of innovation. We are talking that innovation is different, something like approach which initiate different changes and which would be connected with different areas of digitalization. So please, maybe may I ask you to summarize maybe our panel battle. What is your personal view?
Okay, thank you. Actually, I still don't understand what the innovation
because for me, for our company, most of the things are already implemented. I mean, electronic charts, I mean, position control, I mean, communication with the office, we have operational center, we do everything, view if fleet online, position, also what's happening on board. So, I don't know what you are talking about the future. It's already reality. That's all what I can summarize regarding this one.
Thank you. You know, that I think that your company is really very modern and advanced. We all know that SCF is really the age of new technologies implementation. So if you say that you have almost already everything in place, maybe this is your reality. Do you want anything to add?
Yeah, if I may, I'm sorry to try to say again. When we are talking about navigation, the matter of terminology. Navigation is term approved by IMO. It's not regulation, but it's very clearly defined term. And with, I may be wrong, but number of the descriptions of the navigation is approximately 10 or 13 points. Absolutely clear saying that navigation is integration of shipborne equipment with shoreborne equipment only in relation to navigation of the vessel. It's absolutely clear idea, absolutely clear scheme, which is mostly ready to be implemented on technical terms. And my colleague from Korea tried to say the same. If we say in navigation in kitchen understanding, I'm sorry for term, then yes, you're right, it might be umbrella, maybe idea, maybe future developments, but it's a different way. If we are talking about absolutely technical term, which is again clearly defined by IMO, then it's a little bit different story.
I agree with you.
In this, sorry, I'm trying to conclude. In this situation, if we understand the navigation as it's understood by IMO, then in navigation something different than digitalization of shipping industry. Digitalization is much more, is at the angle of view. Okay? Unmanned vessel is other story we will discuss next stage.
Yes, my question is, you remember the title of our first panel battle, digital navigation versus e-navigation, yes? So my question, to try to analyze our discussion, maybe we should talk already not about e-navigation, which I agree with you, from formal point of view, pretty clear definition and concept. Maybe we should talk about digital navigation, which is much wider area, including both e-navigation, digital platforms for logistics, smart systems for fleet management, and etc. What is really required by industry? So you remember the initial question. What is your opinion?
Yeah. Now we understand what navigation means, and then of course we should think about wider approach rather than just navigation. Now it's time. It was impossible to do so 10 years ago when navigation idea first time came on the scheme. But now, yes, we can go ahead with more digital shipping world. In this case, we should be careful again with approach which may not be reached, like in navigation. If the target is somewhere in the sky, then we may never reach it in navigation. Again, the concept which never been implemented fully. So if we say about some real task, then we should divide on separate clouds our further developments. That's in navigation coming to digital navigation, not full shipping, with unmanned vessel as part of the development, and commercial digitalization of shipping, or digitalization of commercial part of shipping. Of course, they overlap in something in some extent each other. But once we clearly understand one direction, another one, and then overlapping area, then we may reach the goal. That's my feeling. Thanks.
Okay, thank you very much. Colleagues, so actually we have finished our the first panel battle. I would like to greet our speakers. Colleagues, thank you very much for your very interesting. And now we are changing the team to the second panel battle. So colleagues, gentlemen, please take your seats in the hall. And I would like to invite to the stand and please change the place of speakers as well. I would like to invite speakers of the next panel battle dedicated to unmanned shipping. Please greet our next speakers. I would like to introduce them. Alex Danskoy, Managing Director of Engineering Center of Shipbuilding AME Group. Jukka-Pekka Tallinen, Autonomous Ship Model Test Project Manager at Arctic, and Alexei Rachmanov, President, United Shipbuilding Corporation. So, please, welcome on board. And I don't want to waste time, and I would like to give the floor to our first speaker of this panel battle, Alex Danskoy. Please open the presentation on the screen. The first presentation of our panel battle, please. Alex, please, your turn.
Thank you, and may I ask for the joystick?
Clicker, yes, please.
Dear ladies, dear gentlemen, first of all, I wish to thank Marinette and Port News Marine Information Agency for the possibility to be in this room and to provide this presentation. Let me introduce myself and our companies. I'm General Director of Engineering Center of Shipbuilding. It's a design and project bureau located in St. Petersburg, Russia. Now we are developing our area of service and obtained a rather small but anyway shipyard. We expect to provide full service to our customers, not only design and project, but also shipbuilding. And our partners, joint stock company Air and Marine Electronics, we met 2 years ago and going in one folding in one group of companies, trying to obtain synergy between Maritime Electronics and shipbuilding itself. Let's say we are going for commercial shipping sphere, common for Engineering Center of Shipbuilding and rather new for Air and Marine Electronics. Now speaking about unmanned shipping, I wish to stress on the theme of Air and Marine Electronics and have introduced our partners. This company, Air and Marine Electronics, is one of the leading companies in the field of control system, optoelectronic, radio electronic solutions, radio engineering, hydroacoustic equipment, and specialized maritime equipment. On this slide you can see all the spheres in which AME is involved. And so you can see it was practically clear that the quality of these services transferred, the quantity of these services was transferred to the quality, resulting for integration of all these elements, developing of smart system, and manufacturing these complex systems as well. One of these development management decisions was prototype, no, not prototype actually, it's a real model of unmanned surface vessel board, named Seeker 2. It was realized some time ago. I have to stress some ideas implemented in this board. First of all, specification general maximum speed 23 knots. Cruising range up to 800 miles at speed of economical speed of 9 knots. She can carry up to 500 kilograms of cargo, having the dimension of 8 meters long, 3 meters breadth, and the height 3.5, 345. Operated with two engines, diesel engines, each 220 horsepower with water jets. And also this boat is supported by a mobile command center, providing radio communication, automatic workstation, and possibility of its exploitation, monitoring. Here, AME realized 3 kinds of control modes for this board. It's manual control, standard for every board, of course. Remote control from the remote control panel, display, steering wheel, joysticks, throttle lever, and etc. And the most interesting, let's say, it's a kind of intellectual kind of controlling the vehicle by itself, using expert system and intellectual artificial, let's say, elements of artificial intellect. For the cases when the remote control lost, or this board have the local area task, which can be performed without operator at all. That is the main task, which is now developing AME for the future technical decisions. Generally, the such board was tested in several regimes. It can perform navigational, hydrographic, and meteorological support. It can be a remote controlled firefighting board, having on board remotely operated firefighting robot, electro-optical models, TV cameras, rangefinders, and floodlights. It can perform rescue, search and rescue activities, rescue missions, having on board rescue dropping equipment, also floodlights, and first of all TV and IR cameras, allowing to perform the search and rescue at sea.
Okay, please keep in mind that you have some time limit on the air.
Okay. So that is our board in testing mode. And on this scheme, this block scheme, it presented, let's say, a general scheme of operation and control of every unmanned ship, having external sensors, integrated navigation system, internal marine and engine room system, onboard management system, software and hardware operation communication system, remote monitoring, and the external manual control system. I have to stress that these blocks you see in blue color are the blocks which are fully produced and designed, developed, and manufactured by AME itself. So more than half of the system allowing to monitor and control this boat manufactured and produced by our company. Some slides later on shows the production of air and marine electronics implemented on the unmanned vessels. I will be a little bit speedy. Here in the left, the bottom corner, you can see how monitoring system identifies various types of ships and vessels and external objects while it's navigation at sea, and also tracking of all the objects, of several objects simultaneously to provide monitoring of external situation and safe of collision avoidance. Common product for AMA is integrated navigation systems, including panels and composite hulls of this equipment. You can see we are doing our best in human-rated interface suitable for operator, ergonomic type of operator. Here also one of the tasks AMA designs and manufactures positional and special-oriented models. On-board management system also is one of the aims already developed and producing. On-board management system, shore-based center which we produce can be mobile, can be stationary, and various modes of transferring video data allows us to provide most effective monitoring. After successful testing and development of this remote operating boat seeker, AMA started developing solution for autonomous transport vessels based on tested technology. We named it a smart ship set of solution, integrated bridge system, including enhanced autopilot with automatic divergence from sea objects, combined optoelectronic radar IS recognition system, integrated vessel control system, automated alert interpretation system, and other ones. Our plans in this respect include that we'll try to implement our works in this year, 2018, on a series of bulker and a small tanker. And later on we are going to deal with the ferries and icebreaker ships according to our preliminary plans. We have to stress that, of course, we understand that e-navigation, digital navigation, unmanned navigation, and handmade navigation are only the tools for shipping companies to perform the task in commercial shipping. For example, delivery of cargo from port A to port B, fishing, dredging, and etc. Of course, we understand quite well that all these means of unmanned and automatic navigation are tools for which could be either suitable or not suitable for exact task which shipping company and ship owner have to resolve. Our aim is to provide the most efficient tool in the right place and for the right task, allowing to shipping company to obtain benefits.
Sorry, I have to remind that the time is So, before we go to discussion, I would like also to put on the screen presentation by Aker Arctic and ask Ika to say about your project, please. Mm-hmm.
Okay, my name is Jukka-Pekka Sallinen, and I work as development engineer in Aker Arctic Technology, and our company is focused more on ship design, but we also have model test facility in Helsinki. And today I'm going to give you a presentation about our autonomous ship model test project. First short presentation and then video from the actual tests. So our first autonomous ship model test, it was done in June 2018, and it was presented in International Marine Design Conference. For the model, we decided to choose this small passenger ferry with 2 azimuth thrusters, one in the bow and one in aft, to get as good as possible maneuverability for the vessel. We had to use our in-house built azimuth propulsion units. They were originally designed for dynamic positioning tests in ice, but they were actually quite suitable for this model test project. And earlier we also did cooperation with Navis Engineering on ice DP systems, and that's why we chose Navis Engineering also for the partner for this model test. And Navis Engineering dynamic positioning system provides this thrust allocation system for the model. Dynamic positioning and autonomous systems, it requires GPS and gyro compass, and we decided to simulate it with this motion capture camera system. Obstacle detection was handled with LiDAR cameras. We used these inexpensive hobby-use LiDAR cameras for this project. The route of the vessel, it was not preset, but we developed software for dynamic route planning for this project. And in the background of the whole autonomous system that combines together all these devices and software components is distributed intelligent vessel components framework, and it's developed in our company, and with this framework we could easily integrate all the systems and software components that were required in this autonomous system. And the best part of this system is that it requires only really little configuration itself. You can attach or remove components from the network without any configuration. Only thing that you have to do is you tell for this centralized configuration node what kind of messages are going through the network. Our aim wasn't to develop any autonomous algorithms in that sense. Our aim was to give the proof of concept that we are able to model these autonomous systems, and our facilities are ready for the developers. Is it possible to get the video a bit bigger?
Sure. Alex, may I ask you to put the video on the screen, please?
So on the video, on the right side of the video is what the computer actually sees and how it navigates. The purple color presents the route that computer decides, and the green line is the the command that is given to the positioning system. And the gray area is the area that LiDAR cameras cannot see or detect, so it's classified as unknown area, so you can navigate there. And white area is free area, or at least what computer thinks it's free, and the black area is non-obstacle. So here you can see when it starts to navigate, it cannot see all the obstacles, so it just creates the straight course. But as soon as it realizes that there is obstacles, it changes the route.
By the way, these examples of artificial eyes, are they moving or not?
They are not moving.
Okay.
Yeah. And like I said, that we use these a bit more affordable LiDAR cameras, so the vision of the cameras are pretty limited to say to 8 meters, which was sufficient in our basin, but then it also causes that they can't always see what's coming.
Please switch again to the presentation. Continue.
So this was pretty much my presentation. If you have any questions, or if you're interested about model tests, then please visit our stand, or you can contact directly to me.
Thank you, Pekka. I think definitely there are many questions, but I would like to ask technical questions or specific questions regarding the project. Maybe we should discuss during our nearest kickoff break. And now I would like to first of all to ask to put on the screen our next question for the voting. So again, I would remind that everybody in this room, as well as everybody viewing us via broadcasting, can go to the website and to cast a vote for this question. So, my question is very simple. Do you believe that such test projects, which we see, for example, today, or which were announced today by Alex, that this test project confirm possibility or feasibility of unmanned shipping in the nearest future? Or this is just something like first R&D probes which are far away from practical implementation? What is your opinion? Who would like to start?
I may do that. First of all, thanks for presentations, very interesting. And if simple answer, then of course yes. It's allows us to believe that in the very feasible future we will receive practical results of such attempts in real shipping. The question what part of shipping would be, whether it's open seas, high seas, or just local roads will be covered by the project, but I'm sure that very soon our seafarers will do their job. That's a negative result of the developments.
Okay. Anybody wants to add to this, I would say, pretty radical point of view? Vladimir, what do you think? Is it really the nearest future, and you guys will lose the job in, I don't know, 5 10 years? What do you think?
Thank you for presentation. This is another two case for me to know regarding such testing, quite attractive. Honestly, we're closely monitoring the progress of this problematic and ready to participate in some particular project here. But right now, as I can see, regarding the class regulation, we got just the principle inside. So nobody knows right now how to build vessel, unmanned vessel, what is the requirement regarding redundancy, what is the class of control, and the regulation just mentioned to us communication between operator, vessel, and mitigating the risk of operation of such vessels. And that's all. So for the time being, nothing to it. We're just waiting the result of the testing. And from a technical point of view, I believe that all technology, mostly propulsion, having experience with deeper vessel are ready for such project. Another case, software and communication needs. So, go ahead, gentlemen. We will join you as soon as possible.
So actually, both of our experts said that technically there are no any problems to implement, and actually, for example, you as a representative of shipping company is ready to take this solution on board, and the only real issue is regulation. And I would like to ask in this case, so maybe Vitaly, you may comment, and maybe Alex, you would add, because as I understand, you plan to start this project already to this year, to next year. So how we should use this regulation? Because definitely regulation is a core, is a ground for insurance, for risk mitigation, and so on and so on.
Yeah, if you give me 3 minutes, Alexander, that's a good point touched by Vladimir. Regulations. Now, as far as I know, no one class introduced unmanned regulations. Not in full scale. It's impossible due to convention requirements at the moment. So the regulation of shipping on worldwide done basing on the idea that some people on board. And 3 players in that regulations: ship owners, crew headed by shipmaster, and the flag state. That's the key figures presented in the current regulations. And I should say that I more recently started new developments towards introduced in 2 or 3 years amendments to main conventions in relation to unmanned vessels, and appropriate working group made first step of job, and currently correspondence group of IMO is working on that. What is done is definition of what does it mean unmanned vessels, 4 categories defined, and 2 of them may be of interesting in relation to unmanned regulations. I don't want to go in details of the problems of regulations, but just a couple of points. Number 1 is technical requirements to vessel construction, which in many cases address to providing human being on board vessels, as well as safety of people on board. I would remind to you that SOLAS Convention was born due to incident 100 years ago to save people's lives at the sea. Now SOLAS continues to be, in most cases, as a tool to providing safety of people on board or people in distress. Another part of regulations also relate to ship crew, preventing pollution of sea through being people on board the vessel. Other part of regulations relate to maneuvering of the vessel, again addressing to behavior of ship crew being on board. And then legal status of vessel is the most, in most cases, described understanding that some people on board who is responsible for ship behavior. We remember that ship is she in English language, and in some legal acts is addressed as part of legal requirements. Then we should talk about liability when something happened, collision or oil spills or other problem. Then somebody should be responsible, and in the first step, shipmaster and his or her crew is responsible for everything happened with the vessel. Also, a lot of requirements to ship crews. We may remember STCW convention and chapter 5 of SOLAS saying clearly that people should be on board and should be provided with some certificates and education and so on.
Sorry,
I'm very fast.
The question is very simple. Is it possible to make this test project?
Finalize. Now, coming back to the initial stage of my intervention, IMO is working hardly with new regulation addressing to the issue. That's number one. In my country, we understand the progress in this step, and we have recently agreed by our government plan how to go ahead with Maritime project. We are working on national regulations, and I hope we will be first or one of the first states in the world introducing possibility of unmanned vessel to be in reality in legal area. 3 points we should do in that. Number one, to provide regulation on technical level, technical requirements to vessel. Number two is regulation on the seafarers who will be not on board anymore, or no seafarers at all. And finally is sea areas which regulated by UNCLOS, for example, in national regulation, and also addressing to behavior of the vessel, understanding that some people on board. So these three directions we are working with now, and I do hope that in the beginning of next year our country will be ready to accept on legal level unmanned vessels. And now the ball on the technical people.
Well, please, maybe provocative question. What you say is actually meaning that we have no any technical issue, and the only point is actually legal issues which are truly saying are not also an issue. This is part of overall discussion about artificial intelligence, where people say, who will be responsible if unmanned car will crash something? Truly saying, we have answers for this. It might be not too much politically correct, but just 100 years ago, we had, for example, in the United States or in Russia, slavery, and we had absolutely natural intelligence, which was property of people. And there were absolutely normal explanations who is responsible. If I'm owning this guy, I'm responsible for his activities. And if I now have artificial guy, I'm also responsible for this activity. But my question, do you really believe that we don't have any technical issues and everything is in place? Please, what is your opinion, please? Yes.
Dear colleagues, my opinion is the following. If we are speaking about the technical aspects, just technical aspects, we are very close to unmanned vessels, and we see no problem in this respect. If we are speaking about the general sphere of commercial shipping, and with all these complex regulations, with insurance practice, commercial practice, and etc., etc., I think in this case many years are still to unmanned vessels. I have to say that we still have on board deck log and the draft deck log and the engine log book, having fulfilled by hands with the blue stamp of Habermas and etc. But we have to understand that we are not doing this project just to do this project, to have the unmanned vessels at sea. We have to perform commercial tasks. If any task, technical or commercial, ship owner wish to perform with unmanned vessel, he can find a way to do this. If it's useless to ship owner, then he will not consider it at all. Let us consider the practice and the task. For example, if we need to perform hydrographic research, hydrographic survey of the small dredging area, aquatorium, no problem to do it now with the unmanned boat. If we, for example, need to have automatic damping barge for dredging purposes with the distance of navigation, let's say 5 miles, with the way out of the main shipping routes, I think it's it can be performed now or in close future.
Sorry, you want to continue in a second. Please, may I ask you to put the results of our voting on the screen, please? Results of the last voting. Yes, please. Continue.
That's my comment, my general comment. Let us provide the proper instruments for ship owners and for shipping companies, and they will decide either it's useful for their purposes and tasks or not.
Yes, yes, please. If you want, you may use the microphone.
One comment in terms of unmanned vessels. I'm sure technology is mature, and if you ask all my colleagues here, they will assure you about that. Infrastructure is not in place, meaning South Pacific we don't have communication. So, or on the poles we don't have communication. And then, cybersecurity is a serious issue. GPS can be tapped. And then you need other means of navigation. Without GPS, you cannot navigate. There are technical infrastructure issues, but I think the biggest problem here is that all the initiative is starting not from the operators. We're bringing about autonomous operation. It's starting from the equipment maker. And the equipment makers cannot think of the autonomous operation. The operators should be the key player. I mean, you have people that are making equipment, and they try to do the autonomous vessel. And what they do it the face with the human. So the problem is to start with the problem-heavy person, to address it through the autonomy. I think this is the key element in this expression. Now, in terms of regulations, they will follow. And insurance companies will definitely insure your vessels, subject to the classification society with type approach. And I can point you 2 or 3 having already rules and do risk assessments, and they go very well.
Well, before we continue, I would like to take your point regarding changes in mindset of manufacturers, of shipbuilders, and I would like Alexei Rachmanov to share his thoughts on this, because I think we came to the point of the discussion where we should think not only about navigation, because truly said, what you said, we discussed before about navigation, but we have many people on board who are not dealing with navigation. They're dealing with the ship, they're dealing with equipment, they're dealing with mechanics and so on. So, okay. Could you please?
Okay, thank you. Is mic on? First of all, I wanted to reply to your last questions of the previous panel and give my feeling of what the real navigation is. As soon as you will be comfortable throwing out all the big maps out of the ship, then you get to navigation. Unfortunately, whatever we do, for whatever reservation channel, for whatever reservation mode, we're still keeping, big maps with the most recent data on it, with depths, with hazardous areas, etc., and the routing, which is done sometimes automatically, always now, mostly automatically, but we still keep this, big maps on board. And as soon as we will be able to throw it out, that will give us a message that, okay, now we're comfortable with that. That would mean, in navigation, real definition of that. Coming to unmanned vessel, I built the first unmanned vessel when I was age 9, in 1973, in my, the House of Pioneers, where we built small models and have them, remotely controlled. Is it really unmanned vessel? In my personal. So, basically, I consider the majority of the models sizes are absolutely necessary, but still toys. And in order to be able to move on to the serious discussion of unmanned operation and operations, we have to really get back to a rethinking of what the unmanned vessel is. Because I have some presentation elements we might not. Okay, for example, automation automatization. You can choose the one which will be the most close to the unmanned operation, but in reality, autopilot is nothing special right now on the ship. So all the yachts over 50 meters, must have. So therefore, if you add a little bit of the artificial intellect, then you can detect obstacles, you can overcome them, you can even teach the big boat how to self-dock and continue all the stories, adding element by element to the whole story. But what's my biggest concern, and this is where we have to break our mind. Last month I've watched again the very, very old movie about Jules Verne's 80,000 Leagues Under the Water, and looked at how the people in the late 60s of the last century have been depicting submarines. With huge sort of steering wheel, with all the elements. All they didn't have is mass, probably, those submarines. That was the way how the people have been really sort of thinking of something new which they never discovered. In reality, a manned vessel also has to be distinct from that standpoint. I will give you one very simple example. As Alex said correctly, what is driving the regulations for that manned vessel is the safety of people, safety of marine crew who is on board. If there is nobody there, do we have to keep the same shape of the vessels like we see here? Regardless, for the last 10 years, nothing happens.
Of course not.
Right. What is our sort of main hazard at sea? Overkill. You put a bottle into the water. Can you overkill it? No. Is it the true definition of what's going to be the future unmanned tanker? No. Right? And basing from that, we have to get step by step into answering these questions, why we do this. And at some point, we can get into very clear notion that all we have to deal with is the infrastructure. I'm sort of new to the shipbuilding, only been in this business for 4 years and plus 2 years in the ministry. Before that, I was mainly dealing with automotive. But you see what is happening now with autonomous vehicles. It's actually a very good example because that industry, unfortunately for us, shipbuilders, is way ahead of us in terms of what they can do, how they, and they're making mistakes. That sort of test already killed 1 or 2 or 3 people because of some, in my opinion, some problems with infrastructure. It's a question of the common protocols. It's a question of the onshore infrastructure. It's a question of signaling systems. It's a question of how we can get order in that part of the area. But there is pretty much clear. Infrastructure sooner or later will become more obstacle than the elements of the infrastructure using. Same story with cars. As soon as you put them fully autonomous, the amount of cars per square meter of the road will increase by 3 times. Simply because nobody's speeding, nobody's carrying on, everybody keeping the distance, everybody going in the right regulation you set for that particular distance of the road, and I can carry on and continue with that. Same story, the ships. We are lucky we have inland waterways which are quite limited, and it's actually a very good model to start practicing. For example, I need to carry a bulker with sand, 50 kilometers one from another, and do it for the next 5-6 months during the navigation. Why not? It's pretty much standard story which we can deal with. But I have to take care of the crazy fishermen who can get under my boat. To take care of people who might overspeed with their private boats, and there can be the hundreds of other things which we have to take into consideration. But after all, the infrastructure should be capable of reacting to that and responding. Basically, securing that autonomous vessel in its particular operation. So therefore, all we currently have to do is, in my opinion, we have to go element by element, making sure what we can do in terms of getting to the fully autonomous vessel through the autonomosity levels, maybe it's the right term. But actually, as soon as we get to the fully autonomous vessel, we have to rethink the concept of the vessel completely from the beginning. And that is the challenge which I see, and we believe that we really have to make sure, how the technology and whether the technology is ready to accept the unmanned sailing vessel. It's definitely navigation, it's definitely radars, it's definitely high-speed internet. Well, we have another example in Russia, it's called Air-GLONASS. 24 satellites, our own navigation system, for which the main task is to send the signal if the accident happens. Pretty much straightforward, so you can call it the black box or the register which you can always searching for when the plane crashes. But the question is, why the technology still does not allow us to send last 20 seconds of the flight, with all these thousands of parameters to the ground, and then basically have all the answers without searching for it. Why couldn't we do it for cars? Why couldn't we do it for vessels? Why couldn't we do it, for any other, moving devices for which the threat of a collision or accident is high? But the reality is, I'm making the 3 circles around my house in Moscow, and I'm losing the GPS connection to that. So the point is, what it's all about. The infrastructure should be ready. It's not the case. Especially if you look at the port infrastructure, you're still far away from, especially, the wave for transfer of the water still has specific. Now I'm getting to a little bit of basic physics parameters. Needless to say, I also need communication underwater. So, are we ready for that? The answer is no. And last but not least, speaking about all of that, so we building the first vessel. It's going to be under the Pioneer M project. It's a 20 meters carbon catamaran, which we built for the purpose of studies for the Sevastopol University, in which we will be testing majority of these elements of this. And I actually answered for the previous question, whether I believe or not that this was helpful. Obviously, the stories are helpful. You need to test element by element, but until we get to a real size vessel, we are unable to understand what is the magnitude of problems that is ahead of us. So therefore, we do this pilot for ourselves. We are happy that the Russian government is co-financing it. We'll be more than happy to cooperate with Maritime and see how these elements will be done. But gentlemen, once again, I think I caught your message on the first panel right. Regulations and infrastructure should really be ahead of us. But we still have having this chicken and egg problem. What should come first? Unmanned vessel or infrastructure? In our
Regulations.
That's the voice of bureaucrat. I'm totally agree, with the point that infrastructure should come first, because then it will have a multitude of the improved services for the cargo, manships, the infrastructure improve. After which, we can put together the vessel, which then can do the job cheaper, because we all know that the man on the ship is 40% of the cost of the operator. So that's our target and that's our challenge. So we'll continue fighting.
Thank you, Kay. 2 points which I'd like to highlight after your speech. First of all, regarding infrastructure, absolutely, I think everybody agrees. It's why we started our today conference with a panel battle regarding digital navigation, which should be definitely infrastructure, correct? And here, just coming back to the major question of our panel battle regarding unmanned vessels, right? Unmanned ships. How the future of the unmanned ships would look like, and I would add when this future will come. Coming back to the first panel battle, you remember that we said that most of our participants planned that in-navigation implementation should be completed till the beginning or mid of 20, correct? And here we see that actually you expect that infrastructure, I'm talking about your roadmap, about the current slide, should be implemented more or less in the same terms. And if it is done, your forecast that unmanned ships actually become a reality in 6 to 10 years. Is it correct?
It's estimates anyway.
Correct. What is your opinion? And my additional question, if we are talking about new approach to ship design, new approach to ship equipment, maybe robotization of vessels, unmanned shipping will come not from navigation, maybe it will come from mechanics, from engine, from new types of design. And to continue the discussion, I would like to ask to put the last question of our panel battle on the screen for voting. So, what is your opinion, please? Because, answering for the first question of our panel battle, is it the nearest future or not? Again, truth and we didn't have battle. Both solution developers, shipbuilders, ship owners, regulators, everybody said that no problem, this is the nearest future, yeah? And the question actually, how this future will be, how to say, how it will come from which route, from which details, from which area? What do you think? Is it just to implement navigation and that's all, and all our unmanned vessels will sail, or do we need anything else?
If I may, I think Alexei explained in very details what the obstacles in the way of fully implementing of unmanned vessels. But when I told about regulations to be first, I was not joking. Even in this room, we mentioned many times soulless vessels, non-soulless vessels. What does mean soulless? Regulations. Every vessel is built in most aspects to be in line with regulations. So if regulations allow to build unmanned vessels, then it will be good signal to industry to do so. So the regulations should be ahead of the developments, even if maybe sound as bureaucrat voice, but it's reality. So I think regulators should work hardly to allow business, to allow industry to develop more fast unmanned vessel projects. That's number one. Number two is technological obstacles. And the first, I agree with Alexei that infrastructure, in wider angle infrastructure, including communications, including port facilities, including even building. Currently, it's impossible in many cases to build the vessel without people on board. We should think on that as well. If I catch your question correctly, from what direction we should wait first step, or the fastest step for further developments from two points, I think. Number one is regulations, to allow again for industry to go ahead, and the second point is infrastructure. We saw the ship itself mostly ready. I mean, I meant ship. Now we should work on design, whatever. That's future developments. Even current design may be used to amend this, so it's maybe not so efficient as might be, but in future it should be changed. No problem. So regulations and then infrastructure. It should be ready. That's my answer.
If anybody wants to add something to this point, please.
Well, actually, I may just reiterate that my feeling is that our on-the-ground people will force us and will show the result much quicker than the shipbuilders and the ship owners. Even the discussions right now in the European Commission of prohibiting the human drivers to drive a car after the 2035, that gives us a very clear signal that A, regulators are first, and second, that we really see the change, because the building the road infrastructure, especially in the intention of preventing the cities in its divine form, is really the only answer is the limitations and regulations. So I actually, despite joking, you're right.
One thing I just want to add, because mostly regulation comment just summarize some experience, meet some technical demands, and even human resolution actually mostly initiated by the class societies here. That's why without the testing and experience of shipbuilding, what kind of regulation we can create and what base for.
Well, but actually, just reminding the first our question, I think that our audience, as well as our speakers and experts, believe that ongoing test projects actually should be the ground for such regulation. So probably if we try to wrap up all our the panel battle dedicated to unmanned shipping, we could say that this is actually the main question: why do not unmanned ships sail? Correct? The title was the panel battle, and we see that first is regulation, second is infrastructure, and to build both regulation and infrastructure, we need actually just practice, and this practice are brought by test projects, correct? Colleagues, maybe our dear guests would like to add some question, comments, please. Do you want to add something? Colleagues, so we are finishing.
Yes, maybe.
Yes.
Sorry, the last thought which I want to share. I only have a very clear feeling that since all the maritime regulation is global and worldwide, the solution of the unmanned ship also can only be done as soon as we reach a consensus, through all the countries. So the oceans and seas are uniting all the countries, and I cannot imagine that this can be done, like in the one part of California with having the unmanned vehicles. Impossible. But they will be first because they can do it locally. For us, to solve this globally, we have to go and discuss all the protocols and the questions of combining all this together. Because without that, we will not be able to build the basis for the implementation of this worldwide. That's, I think, the key question.
Thank you very much, colleague. So actually, the major news after our panel battle, that during our lives we will see unmanned shipping as a reality. So I think this is very good news. And I would like to say that I really very appreciate participation of our experts, of our speakers, of this panel battle, previous panel battles. I thank our dear guests for participation. So, colleagues, thank you very much for participation. I want to thank again RVC and Porteous as our sponsors, and I would like to remind that now we will have, by the way, question, do we need to have a break, tea coffee break now, or should this process proceed to the third part to Maritime Robotics? What is your opinion, colleagues? Coffee break. So let's make coffee break and come back at 1 p.m. for the third part of our conference dedicated to Maritime Robotics. Please, thank you, gentlemen, and a lot. So again, we are online. And after the break, we are coming back to the conference, to the Marinette conference. And today, I would like to remind that we have discussed already digital navigation and unmanned shipping as the two topics. And now we come to maritime robotics. An idea, again, to take as very practical examples, very practical developments which we have currently in different companies, and based on these practical examples to discuss what we have as today of the maritime robotics, what should be the future, the tomorrow of the maritime robotics. We agreed that we will not make a panel battle or even dispute on maritime robotics because we believe that everybody would support that maritime robotics is a very promising and very useful trend of technology. So I doubt that anybody would oppose, would say something against the development of maritime robotics. So what we would like to do now is to take presentation, to take speeches by our speakers, and in a few minutes I'll introduce our honored speakers of the third part of the Marinette conference. And then to discuss actually details and future of the development of this project. So please, I would like to introduce and to greet our speakers of the Maritime Robotics Fest, as we name it, Alex Dansko, Managing Director, Engineering Center of Shipbuilding, Alexander Troitsky, CEO, Non-News Engineering, and Alexei Dobrogiev, Krylov State Research Center. So, colleagues, I would like to propose Alexei to start with his presentation. So, if I might ask to put the presentation on the screen. Thank you. Again, your turn, please.
Thank you. So, I will proceed. So I will proceed with advertisement of aviation and maritime electronics, and will present one more product of our company, our partner, work-class remote operation vehicle, Triton 2. In the program, this item is stated as from Navy to commercial fleet. I will forget the word Navy and we'll discuss the commercial practice and commercial usage of this vehicle. I have to stress that it's heavy class remote operation vehicle with working depth up to 500 meters, lifting load up to 6 tons, and dimension 2.5 meters, 1.7 meter, and 1.5 meter in length. So now we considering this as a hard and heavy remote operation vehicle, which couldn't find on the market, at least in Russia. And also similar models of foreign manufacturers. Let's say the main let's say benefit of this vehicle is of course price, because it's almost totally manufactured by aviation and marine electronics. Here you see the general arrangement of this vehicle. It has the complex of hydraulic manipulators for underwater operation. Also, we have some lifting technologies applied to this work class rope. It's the buoy with the manipulator which can, after fixing the underwater object, can be separated from the vehicle and float to the surface with a cargo rope, further fixing the rope, fastening the rope on board of the mother vessel, and to obtain this object from the sea bottom. Components of this complex consist of three main blocks: container power system, container control system where operator is located, and lifting device with a telescopic hydraulic beam where the rope is based in transport, while transportation, while based on board the mother vessel, and then delivering outside the board and placing into the water level. In this rope can be applied technology of search and position of underwater objects with hydroacoustic scanning, side scan, front scan, and sector scan. Also, one of the main innovations is underwater video camera with laser marker and scale, allowing to fix the objects with a high accuracy. Let's say it can be yes, it can be named smart light, bearing in mind that it is also works as a, let's say, a smart projector. That's my main features, and we'll be glad to, if in case of interest, we can provide more detailed description and specification of this vessel. Of this rope, sorry. Thank you.
Thank you, Alex. Alex, do you have any questions to the speaker? So I have two. First of all, maybe they're connected. What is the commercial purpose of this vehicle? And before we talked about robotics, about unmanned shipping as a replacement of people, of human labor. And is this also a replacement of human work, or is it something like extension of human work? So actually two questions, purpose and what about how it is positioned against versus the human work, please.
The main task of such rope to support oil and gas companies operating on shelf and sea bottom. And of course it's on such depths up to 500 meters, 600 meters and etc. It's almost fully support all the operation without divers, without specialized deep sea divers. And on the depth less, on the standard depth for divers up to, let's say, 100 meters, it could provide the support for manned operations.
Okay, thank you. Colleagues, any questions? Yes, please.
From the Baltic Transport Journal. Is this solution weatherproof? I mean that can we use it in the Arctic, for example? You've mentioned gas and oil projects. as the main purpose of deploying this product?
Yes, of course, but of course with a reasonable approach, taking in consideration of weather and ice conditions and general situation.
Thank you very much.
Thank you, colleague. So, I would like to thank Alexei, and I would like to pass the turn to Alexander. Could you please open the presentation? So, please take a clicker. I remember that you have quite sophisticated presentation, so I hope the clicker would work. Yes, correct?
Thank you so much. For us, it's an honor to be here and to speak on this ground because I present quite a small company. We are located in St. Petersburg, Russia, called Nonius Engineering. We've been focusing for more than 10 years already on quite a specific sphere, that is the automation for the dredging industry. We produce software and hardware for the automation of dredgers of all kinds and supply them not only in Russia but also in Europe and in Asia. So we have quite a serious practical experience in this field that we combine with the theoretical experience being a partner of the St. Petersburg State Maritime Mechanical University. So the experience we've derived from all of our projects and all of our clients, we're trying to combine with the theoretical basis to develop the products we produce. In the Marine Technical University, we are the leaders of the Students Design Bureau, developing diverse kinds of underwater unmanned vehicles, currently being part of the huge contests in Vladivostok, where diverse robots of this type are being compared. And gradually we came to the idea that the simple automation is already not enough for the industry, that we shall come to robotics. Obviously robotics today is a hype word, but our experience makes us feel that really today in the field of dredging it's already a reality, not the future. If we turn to the pluses and minuses of that, as for the pros, we can say that the proper way of doing robotics for the dredging could let us to downsize the crew in a smart way, to put the less requirements for the qualification of the crew and make it more safer for the jobs to be done, and to eliminate the human factor to quite a serious extent. Moreover, that's clear for us that it shouldn't be installed only on the newly built ships. You can robotize even an old dredger. And obviously, enhancing the efficiency of your fleet, you will make it possible to get more contracts, and this shall be competitive advantage, of course. If we say something about what's contra in this field, of course, to launch such a project, to develop such equipment, quite serious investment shall be done. And we all understand that if there is a small mistake in the software, it can lead to big troubles that shall be foreseen. And what's really important that new regulations shall be developed for this field as well as for all the fields concerning the unmanned vehicles, as have been much discussed here today. To make a feeling of the future, we turn to the different sphere that's car making industry also mentioned today. So all the big analytical agencies foresee the huge increase in this field quite soon, presuming that within 10 years the market of the robotic cars will be enormously bigger than now. And one of the good signs of this is that really in the Great Britain, since this year, insurance companies offer discounts for the owners of Tesla cars who use the autopilot mode. So according to the statistics, it's more safe than the traditional way. Sorry. So for us, it's obvious that robotics in dredging shall be developed now, and we decided to start with mining dredgers because that's the easiest sphere to be developed. And we cite each time the words by Oscar Landa, the Vice President of the Department of Innovation with Rolls-Royce Marine, who's here as far as I know, that one should start doing robotics even not when it's everywhere. It shall be done quite before to be the first, otherwise it will be the second. To pay a little attention to the current situation, we have studied the experience of the Soviet Russia that proved to be quite interesting. There were quite a number of quite sophisticated developments in the 80s that were used on dredgers, not only in Russia but also exported. These were, of course, analog equipment, and moreover there were some special equipment for positioning, being the 2D positioning systems of the pre-satellite era. So we are trying to get some inspiration from that to move forward. Of course, this all is totally lost and out of date. So for now, we shall pay attention also to our partners from different countries, and the leader in the field is IHC, Royal IHC shipbuilder from the Netherlands, the leader in the field of dredge building. So they are developing currently such systems for robotizing all types, major types of dredgeries, including backhoe excavators and suction dredgers. Nothing of this is widely sold now, so these are the think tank stuff that's being developed just today. It's like about other players, Vosta, that's not that active today, but still they have announced the special robotizing system for cutter suction dredgers. Van Noord have their own system. We are working with this. That's rather not robotizing system, but a stuff for digitalizing of the working processes on a dredger. And the upcoming leader of dredger building, Damin, at least doesn't obviously admit that they're doing something. When we approached this topic, we've decided to check the market as to the types of dredgers to be worked with first. And if you have a look into the statistics, you see that the most widely used types of dredgers are cotton suction dredgers. So we decided to pay attention first of all to them. And one point that's really important about them, that they are usually non-self-propelled. This means it makes it more easy to deal with norms, with regulations, because the questions of security are a little less in this case than comparing to the situation when you're talking to self-propelled vessel. Moreover, these vessels are widely used for mining in closed water areas. That makes it easier to experiment and to check the developments. To robotize such a machine, the algorithmical base is quite clear to us because we are working day to day with these types of equipment. There is a number of controlling options and the number of the options we shall monitor to develop the special scenarios for the work of such vessels. And what we currently do, this is the example. This was to be video, but for some technical reasons it's just a picture. So it's a real prototype of working robotic cutter suction dredger that receives the information from diverse sensors that can be seen into the upper right corner. And depending on the combination of this data, it identifies the current situation, the current regime, switches on one of the scenarios that is pre-calculated, and waiting for the results of this to switch back to the normal work. And in this case, for example, if a dredger meets a stone, we see several parameters going higher, like vacuum, like tension of the side winch. So we switch on the scenario stone or stumbling block, start raising up the pipe and wait until the parameters go down so that we can go on normal job. This is on the final stage of development in terms of software, and we are now approaching combining this with the hardware. Of course, the next step for the robotizing of the sphere would be the creation of the robotized ecosystem that could include not only dredgers, but the slick barges, all the additional equipment. What's really important, bathymetric survey. That's the field that's being robotized already, as was said today. And this all shall be created like a real ecosystem that would allow to enhance efficiency very, very considerably. So to underline what was said, we say that currently all the robotics for dredgers is done mostly by the dredger manufacturers, and we doubt that's the true way of the development for such systems. So it would be useful to separate the system production from the shipbuilding. And we shall think today about how this ecosystem shall work and be developed to have the basic bricks today and not to redevelop it in the future when we understand how it shall communicate to the other items in this ecosystem. That's the conclusion that we have done for ourselves, so we started moving in this direction. I'm very open to any communication and interaction with other interests, and you're all very welcome to our booth that's in B6 hall. We can show you what we have done, and hope to find understanding from your side. Thank you very much.
Thank you very much, Alexander. Colleagues, any questions, comments do you have for now? Yes, please. Sure.
Thanks a lot. Very, very useful and meaningful presentation. And I have a couple of questions. The first one, initiated from the similar conference we had in Russia a couple of weeks ago. And on the similar presentation, one of the ship owners' representative told that it's impossible fully make automatic dredging process, since in some cases it is necessary opinion or decision or feeling of the operator, feeling of structure of the surface dredging, or I'm not expert in that. So, and on opinion of the representative of the ship owners, in the current situation, it was impossible to fully robotize the process of dredging. That's question number one, whether it's true or not, and whether it's possible to make it fully robotics. And question number two is legislation, since I'm from legislative part of the industry. You mentioned in the presentation that lack of legislation and lack of regulations, and nobody knows what's coming to address in the technical developments. It's not quite clear what did you what you meant, since if we are talking about shipping itself, in general, in shipping, and if we talk about this dredging unit as ship, then it's clear it should be addressed somehow as any other ship with some particulars. But if in dredging process, I don't see anything to be regulated for unmanned or automatic dredging as process. What did you mention? Legislation in general for shipping, or something specific for dredging process? Thanks.
Thanks very much. Regarding the first question, working directly to the crew of the dredgers and to the dredger owners, we know that this sphere is extremely conservative. And actually, what we currently do at our product is not the robotizing, but automatizing system to visualize the dredging process that makes it times easier for an operator to see what he's doing underwater. So in modern world, it's used everywhere. But there are still captains that understand that in case such system would be in place, they would be removed by the younger crew members. And they claim that they feel with their fingers the density of the material, and nobody else could supply the same expertise. And of course, we have to battle in the way with this, as it's usually done with all the innovations, saying, okay, look, here is the current situation, here's the overall efficiency. If you take your year instead of the shift efficiency, you'll see that the year efficiency of the production will rise anyway in case you include such system, and maybe call the second captain being a little bit younger and less, of course, experienced in the field of filling all the material. So in terms of possibilities, we find it absolutely possible, and we see how it's possible, and actually we see that analogs developed by IHC, for example, are really working, and we have seen the excavator filling the barges, working in a totally autonomous way. The only duty of an operator was to sit there looking around and once a minute push a button to confirm that he's on the spot. That's it. So it's working. So we see the future for that definitely, and we understand that the efficiency will rise and the security of the overall process will also rise. And so the second question, you're very right. So dredging consists of, in a way, two processes. First, the ship operation, and another is specific technical question of dredging. And what we pay attention to in this case is the very small part of the regulation for shipping that concerns dredging, because we have shown a picture in the presentation with the special lights to be lit on a ship while dredging, because the behavior of a working dredger on the water is quite specific, and it differs from the behavior of the normal ship going to and fro or staying somewhere and so on. And this small regulation question of interaction between a dredger that's doing the dredging works on the water area with our other vessels shall be taken into consideration while developing the overall regulations for that.
Thank you very much. So, if my understanding is correct, that technically speaking, strictly technically speaking, no problem to make fully automatic scheme for dredging.
Yes, we claim so.
So
it's challenging, but
the question only with the crew or human.
The question of development.
Human feeling, yeah, it's understandable. And so my conclusion might be from your answer that now you are losing resources providing crew with the information which is no need to robots visualizing and providing them with some.
I wouldn't say so, because these systems that are to assist crew is the basis for development the next stage.
But if remove crew, you no need to develop a system scheme for crew.
In a way, yes.
You may jump from this stage, globally speaking, not in relation to particular situation. I fully understand that captains who spend their time, full life with his or her job now close to lost the job. So I remember that восстание ткачей.
Sabotage, yes.
Russian pension reform signal.
Thank you. Yeah, that's right. I would add just a few words. Maybe 15 years ago, in the beginning of my career, I worked with mining companies. And I remember absolutely the same skeptical approach that, listen, it is not possible to automate coal mining because you need to feel intuitively, to feel the material, you need to feel the process of mining and so on. Just recently, I saw many articles, technical articles, when I see that there is any person, any miner in call phase, operator just sitting, I don't know, 100 to 200 meters outside, and they're producing calls in months more than before during the year, you know. So I would say that probably you're absolutely right. If you show the practical real result that this is working, I doubt that any mental or how to say human
elements.
yes, the problem would prevent, because eventually it's all about economics, it's all about revenue, it's all about profit. If you can generate money 10 times more using robotics, definitely it will be the major argument why to implement this robotics. Thank you very much for your presentation. And I would like to ask Alexei Dobrodiev to make his presentation. Could you please open the presentation on the screen? Actually, initially when we discussed, we said about how to name it, nuclear transport drone, meaning that this is fully unmanned, not just low crew, but fully unmanned vessel, which can be used for the nuclear industry. So, please.
Yes, thank you very much. So, my name is Alexei Dobrodiev. Yes, I'm presenting here the ICE laboratory of the Law Center, in particular ICE Model 10. And I would like to introduce here some maybe situation in the projection of ICE-going ships, and I would like to introduce maybe some steps in projection before developing autonomous ships, because there are a lot of problems in this ICE technology. So, Closed Research Center, in cooperation with other companies, is currently developing a digital model of drone ships for transportation of different nuclear waste. And this drone ships, ship design means that there are no accommodation spaces and life support system on these ships, maybe more hold spaces for increased cargo capacity, major improvement in hull design, and other points. But according to the latest studies, cargo vessels should be able to travel through North Sea Road at high speeds to make it commercially competitive road. And the most effective logistic solution for maritime transportation of cargoes from remote northern regions is provided by heavy tonnage Arctic class vessels. And cargo transportation from the Arctic regions should be carried out not only in the western direction, but also to the countries of the Pacific region, such as China, Korea, Japan, and others. And here is presented the table where provided the data by the Russian nuclear icebreaker owner about distances and time required to deliver cargoes from the Yamal Peninsula and the Persian Gulf to the main ports of Asian and European markets. In the coming decades, the merchant fleet is planned to be replenished with a good number of high-capacity vessels of very high ice class. And from experience, the best option in terms of cargo transportation, time and navigation safety would be to operate cargo carriers in ice channel behind the powerful breakers. So, slow speeds of merchant vessels sailing independently as well as under icebreaker resistance appear to be an important issue, and at present this problem is mainly solved only by mobilizing of two icebreakers to lead large ice vessels through the Arctic Ocean in very wide ice channel. Operating conditions in eastern Arctic are much more difficult than in the western part, and the marine transportation system has to be configured accordingly. The requirement for fast and year-round shipping in the Arctic was confirmed by Director General of Rosatomflot in his interview of Kommersant newspaper, and here is presented the plans of the future years. And here I can tell you that the cargoes moving via the North Sea Road should be grow to the 75 million tons. So here, icebreakers should be capable to sail at high speeds in 1.5 to 0-meter thick ice, and model tests conducted in our ice-10 have confirmed that the advanced nuclear icebreakers designed and built at present, such as new Arctical 60 megawatt and projected icebreaker leader of 120 megawatts, fully satisfy these requirements. The large-size carriers is also to meet a new requirement to sail at the same speeds in a channel behind that breaker. So, therefore, such as breakers open the possibility for making some drone ships or autonomous ships which will move in ice under the icebreaker spotting in the channel behind the breaker. So, a series of these tests was performed in ice basin of our center to investigate the behavior of heavy tonnage carriers in ice channel behind prospective nuclear icebreakers. The upper figure here shows the schematic drawing and main design particulars of our Krylov Center. So, an example of testing program is presented on this slide. Models of icebreakers and model of carrier were manufactured to the same scale, 1:40. And the main task of this experiment is to model the carrier sailing in channels of various widths. So, self-propelled models were carried out in tests of 1.4 and 2.40 meter ice. So, studies on ship behavior in ice conditions are essential in the development of common IT environment for crewless vessels, drone ships, which provide an input for integration of available automation tools into a comprehensive IT system. So, for example, is online mapping information, some locating of ship and other objects, environment conditions, and other. And an additional advantage of economic benefit may be to be achieved by suitable changes in principal dimensions and hull design, as well as lower fuel consumption. Moreover, drone carriers are considered as a useful option for transportation of some dangerous cargoes, in particular radioactive materials with a reduced level of biological protection. Some work plan for development of drone ships is presented here. For example, is some elaboration of information for model autonomous operation, development of unmanned bridge concept, and design of drone ships, and other points which you can see on this slide. And there are some ongoing projects of Krylov Center undertaken to achieve these goals. So, for example, now development technologies of tactic and operational control and planning for icebreakers and ice-class vessels in support of year-round North Sea road navigation. Krylov Center has already developed the special purpose software for comprehensive analysis of marine transportation system based on common ship design and fleet management approaches. And for the finishing, moreover, we are also engaged in development of full-scale simulation methodology, which intended to describe icebreaker operation in ice based on Russian-made software packages, including a full range of relevant numerical models for describing the moving of ship in ice. So, thank you very much.
Thank you very much. Colleague, please, questions, comments? Yes, please. Maria.
I've got a question. Are you in any way bulletproofing, so to speak, your solution against cyber risk? Because I can imagine a situation that somebody would hack a drone that carries nuclear waste, and then this would pose a serious threat to nature and humans. So my question is about cybersecurity of the whole venture.
So I would like to just say that this conception of drone ships for moving of nuclear waste is some only idea, maybe for some example, because the main problem here is the development of the whole system for creating the autonomous ships for ice conditions, because we don't have now at this moment some simulation models for describing the ship moving in ice conditions. I think that is more main problem when we begin to start projecting of autonomous ships. So it was only some maybe example, yes.
Thank you, please.
Yes, please. One question. Could you please tell your opinion in respect of first, who deliver these drone ships to the point of starting of ice convoy? What will be with these drone ships if they will be anyway blocked in the channel after icebreaker? And who takes these drone ships in final point after ice convoy complete?
Yes, thank you. It's very interesting and good questions. But of course, I think that some response on these questions is the second stage of this work, because on the first stage, of course, the most important is the development of some simulation model for moving ship in ice conditions. But if I begin to answer on your questions, I think that if we can make the autonomous ships for ice conditions, I think that it will not be a problem to make the possibility for moving ship to the beginning point of future moving in ice conditions behind the icebreaker. Because the moving in ice channel behind the icebreaker is very difficult, has very difficult process with interaction between ice and ship hull. And I would like to say that now at this moment we have more exact models for moving of ships only in level ice, but never in Arctic you can see only level ice. You can see the ice ridges, brash ice conditions, maybe some rafted ice and another. Therefore, I think that we can begin to use autonomous ships in ice conditions only after they describing all the scenarios of ship operation in ice conditions. And if we make it, I think that we will not have any problems for delivering the ship to the start point and for the delivering ship from finish point to the port.
Can I understand your opinion? But drone ships must be under some one operation, and just the task to perform the voyage through the North Route must have a sense. For example, if you wish to deliver these drone ships to the Asian ports or Japan ports, somebody must take to its operation these drone ships after the completion of ISS core.
Yeah, I agree.
How this system will work in this case? For whom these drone ships will belong?
I would propose to take, for example, your unmanned boat, which is already in place, and he can actually just guide this drone ship caravan.
Yes, for escorting ship to the port.
Yeah, confirm its commercial point of view. I appreciate it very much.
Yes, okay.
May I ask also one more question from my side? You said about one of options how to utilize such kind of drone ships is to transport nuclear waste and so on. And what type of engine do you plan to implement within this drone ship design? Is it a nuclear engine as well?
I think that it should be, of course, diesel, because now to use a nuclear ship for autonomous idea is maybe not so good decision.
And do you believe that diesel engine could work without any presence of human personnel?
Not of course, but now in our conception, which is planned to develop in future, we think that some representative of crew should be at the ship, but a very small team for only controlling some dangerous situations and for making the main procedures on the ship. Only.
Thank you. Colleagues, yes, please.
May I ask questions about market reason of transport nuclear waste through the flow of Russian why it needed? Do you have a market research?
So actually, the question is asking, do you have a real business case for this, or is it just some abstract concept?
I think that it's concept, of course, because all this idea is a big concept. And why is nuclear ship? We develop now not only a nuclear ship, but I think that is a good example for development of this idea of autonomous ships for ice conditions, because transporting of nuclear waste is very dangerous operation, and of course you can load the not good effecting on crew of ship if you use the drone ship. But I think that is question of future, of course. Firstly, we will make ships not for transit of nuclear waste. I think that it will be maybe for different oil and gas transporting in Arctic.
Thank you. Alex, any questions, comments? Thank you very much, Alexei. So actually, this presentation, we are completing our third part of the conference, and I would like to thank all our speakers. So please greet our speakers, please. And also all our participants, both who attended us in this room and who viewed us via broadcasting on the website. And I appreciate supporting of our conference by our sponsors RVC and Media Group Port News. So, colleagues, we are closing the conference and we'll have time for informal conversation. Again, thank you very much, ladies and gentlemen. Have a good day. Thank you.